Alright, so today we'll be talking about derivatives. So first, a quick overview, we'll be going over the definition first, some techniques of taking derivatives, and then a quick application. First, the definition is the rate of change, or the change in y over change in x, which is also a similar definition to the slope, because the derivative of a function can also be the slope at any given time. The first derivative can also equal the velocity of the original function, and the second derivative of the original function can equal the acceleration. The more formal definition would be f of a plus the change in x minus f of a all over the change in x, where a is just the point at which you want the derivative taken. So for example, if we just have the graph y equals x, we see the slope of this graph is just at an even keel at a rate of 1. So we would expect the derivative of this graph to just be a horizontal line because the slope wasn't changing in the original graph. But if we look at the graph f of x equals x squared, the derivative is not the same at each point because the slope is changing. Like at point 0, 0, the slope is 0, where if you get x values greater than 1, the slope is increasing, and if you have x values less than 1, the slope is increasing but negatively. So therefore, you get a line as the derivative, f prime of x equals 2x. And so if you plug in x equals 1, your slope for the original function would be 2. And if you plug in x equals negative 1, your slope of the original function would be negative 2, which makes sense. So some basic techniques of taking a derivative. We have the power rule, so this is just if you're taking any function to the power of something. So if you have x to the n, you just drop the n down in front of the x, and then take the power subtracted by 1. So for example, x squared, you take the 2 down in front of the x, and the power of 2 minus 1 just gives you 1, which we don't write. And then Brandy will take over with the product rule.
So the product rule is just taking the derivative of two functions multiplied together. And to do that, you just take and you leave, so you take the derivative of the first function and times it by the original function for the second one, and you leave that alone. And then you add the original function times the derivative of the second function. And so in this example, you have 2x to the 6 times e of x. So then for the first half of it, you would take the derivative of the first function, which you would get 12x when you bring the 6 down times the 2 and times x. And then you multiply that times the second function, which is just e to x. And then you add the original function for the first function, leave it alone, and then times it times the derivative of the second function, which is just e to the x again. And then another technique is the chain rule, which is taking the derivative of a function within another function. So then to find that, you take the derivative of the first function, leaving the second function that's inside alone, and then you times it times the derivative of the function that's inside. So in the example, we have e to the 5x squared plus 5. If you take the derivative of e to the function up to the top, and then you times the derivative of the function that's in the inside. Then this one is also using more than one rule, as you're also using the product rule inside. Also, the power rule, not the product rule, sorry. Then you can have another application is the quotient rule, which is taking the derivative of a function over another function. And to look at this, it's easier to think of it in terms of the low d high minus high d low over low low, which just means taking the bottom function, which is the low, times the derivative of the high function, which is the top function, minus the high function, which is the top function, times the derivative of the bottom function, all over the bottom functions times itself. And in this example, we have x squared plus 1 over 3x to the third plus 7x, which would just be doing the low function times the derivative of the top function minus the top function times the derivative of the bottom function, all over the bottom function squared. And we just have an application. In this one, there's some data points on your driving and your distance that you've traveled, or yep. And then, so at the first part, you're not going anywhere, so you start at 0, 0, and then you're accelerating, so the line goes up, and your derivative just represents that you're going up at a constant speed, so it would just be 2. And then for a while, you just go, you don't accelerate or you don't decelerate, so the derivative is just 0, so it's constantly at 0. And then you decelerate, so then it goes negative. So then this here shows your velocity and acceleration in the graph. And to conclude, there are many applications other than just velocity and acceleration. And also, once you know all the rules of the derivatives, they're relatively easy to solve, as they all kind of go hand in hand. You use one and you can use another one inside of it. And then it also goes hand in hand with integration, as integration is just basically doing derivatives in the backwards direction.